Right. Hello, good morning. So we were playing around with the impact debugger yesterday and figured out how we want to do it. And I thought we would just kind of finish it. And let's see here. Let's build the latest stuff. And let's see if we can find the dev server. I guess it's here. Cool. So this is what we're seeing now. We're seeing two events for the state. And that's the reason it's just strict mode. It doesn't matter. And we have a reference to, we use the store container as the reference. Because the store container, let me just check the code here. Yeah, it's anonymous because the store container is what creates the hierarchy of the stores because it might have a parent. And then store ref is the actual function used for the store, so you can grab the name there. We just don't have a name here. Let's do that. Function counter store. So if we refresh, you see we have the name. So that gives us what we need to kind of display the store, or really like have a reference for the store instance. That's my point. So that store container will be used internally in debugger as a reference to the store to figure out where it is in the actual UI of the debugger and where to update things. And then we have a state event, which just gives the full state. So we can just kind of put that in the UI. And then we have props. So this just gives basically the props object coming into React whenever it reconciles. Again, it just has the store container as a ref. And then we have store mounted, which has both the store container and a component ref. And the reason for that is we're thinking about like you being able to kind of click the store in the debugger and then it highlights it in the UI. But I'm not sure exactly how to do that because I'm grabbing a fiber here. I'm not sure if you can actually access the current component properly. It's something we have to explore. I'm not sure. And then we have unmounted, and this triggers because of strict mode. But anyways, we have all our events now. So the thing we need to do now is really just continue implementing the this thing where I haven't really explored using an array. So let's see, we don't need to do this now. We can just do state. And let's create an array here. So list title foo. And then let's rather do state list 0 dot title, and then we're gonna list what are we gonna do? Yeah, let's just make this a button, change name, and then let's do this, and then we'll do this. State list map item index li key index item dot title. Yeah, something like that. What does the state look like now? Okay, that's nice. That kind of just works, right? Why does it just work? Yeah, because it's an observable and we just traverse it yeah, so the point is, does it actually update here? And it does. Okay, so it works with arrays. That's great. And if I were to like add something, add lists, push title, boo, add, that also just works, right? Yeah, okay, this is great. I think this is actually good to go for MobX. Cool. And then we need to implement it for the others. So let's just start on legend here. And this receives store value, update debugger. And what we want to do here is very similar. I think it's called observe. And it has the same signature. It's the same concept as auto run. Just 2 seconds. Oh, for fuck's sake. Sorry. Cool. So it should be simpler with legend because we just need to find like the observable, and then we just run get on it, and that will actually observe any changes. We still need to do state and then update debugger state. And we still need to go through key in store value. I guess we want to have, what the hell? Still want to do like a traverse thing. Value any, let's see. And let's do traverse store value. Oops. Store value. And I'm not sure if they actually have kind of like an is. Yeah, they have is observable. So what I think we can do is so if is observable, in this will be in value. If is observable value key, we're just gonna do, yeah, so we're gonna do the same here. We're gonna have a target. I'm gonna do any here, and here the target is the actual state. But if it's an observable, we're just going to say target key equals value key. Let's call it nested value, just a value key. Nested value, and then nested value dot get should be enough. And then we can just continue from there. And if this is not the case, if oh, wait a minute. One thing I'm not taking into account here is if the actual store value is an observable, which could be the case. I don't think I do that in MobX either. Oh, this traversal should be a bit different. The check should actually be on the value. Okay, we'll change that in MobX as well. So if the value is an observable, fuck. How should we do this? How should we write this? Hello there. Good morning. I think it's fine that we do this because you won't be adding and removing stuff to the store value anyways. Like it is a static object, even though it's observable. So it doesn't matter. So let's just keep this, and then if type of nested value equals object and nested value is not equal to null, we want to keep traversing. Or what we want to do is we want to say nested value, target key equals this, and then we want to traverse the nested value, and the target now is this object. So this handles like just having nested domains in your store. Yeah, I actually think this is it for legend. So let's try it. Let's try it here. Let's change to legend. And then we're gonna import from legend app state. And yeah, I think we can try to do this. So what we're gonna do is, yeah, so legend is a bit different. Oh, interesting. Oh, so our type for the store. So this doesn't, that's interesting. Why doesn't this, so this isn't actually, okay. Index signature for type string. Is missing. So this doesn't have, that's interesting. Observable object. So observable, oh, this is a complicated type. Oh, read only key of, okay, I know what's wrong. It's just because we have this explicit typing return type of the store. We should check that first. So store, type store. We expect this to be a record of string unknown. It's a bit weird that Can we just say object then? Like, we shouldn't really use object, but I think we need to do it here. What does this do to the... let's add another... I'm not sure if this actually fixes it. We need to fix it on create store as well. That is interesting. Oh, manage. No, that doesn't do it. That's interesting. Yeah, but maybe we shouldn't have that. Where the hell is the thing? Maybe we should just do T, and then we rather need to check in the... Yeah, let's do that. Yarn build. But at least now this should be fine. What? Oh, wait a minute. I think I know what's wrong. We need to build this one as well. There we go. Yeah, the thing that happens is that it's just when we implement this thing here, store value, it's not necessarily actually a record of string unknown. But maybe we could handle that in the actual store implementation. So where the hell is it? Debug listeners state. Here we are. So the question is, what do we do if you're not returning an object? Which would be insanely weird. But I think let's just have that check there. And then that's something to deal with later. And type of current equals object, and store dot current not equal to null. Yes, let's just do that. And then let's look at the actual implementation here. Yeah, we're implementing a debugger for impact. So basically, where is the... Do I have the slides here? Yeah, so like, because impact is, it kind of normalizes the usage of reactive primitives with React. So you get this store concept, which is like built on top of the React context. So instead of having just global stores, you're able to provide these reactive stores nested in your component tree. And it guarantees that it's like concurrent safe, you get automatic observation in components, and you have fast refresh. So you can like lean into the like your favorite reactive primitives, but then you have a really nice encapsulation to actually use them with React. And it's kind of nice that you get all of this out of the box, regardless of using MobX, Legend, Preact, or this reactive primitives that's coming from Impact. And I want to add something to this list, and that is debugging. So it doesn't matter if you're using MobX, Legend, Preact, or the Impact signals, or whatever else we could add there. Like we can add the view reactive primitives if we wanted to do that. But the point is, this store encapsulation allows us to actually create a debugger where you can see the stores, and you can click the store, you can see what state they provide, you can see what props they receive. Whenever you change the state, you will see a history of state changes in each store. And again, it doesn't matter if you're using MobX, Legend, Preact, or any other reactive primitive, it will just work. So that's the fascinating part here, is that we're able to kind of create this like fundamental developer experience of using state stores in React, and then it's much more flexible on how you implement the actual state in those stores. But you kind of get all this good stuff out of the box. So what I'm doing now is that I'm just implementing for each of these packages, like MobX, Preact, Legend, and the signals, impact signals. They are currently configuring, let's see here. They are currently, this is the MobX package. So its create store function is derived from this configure store. And it has an initial, it had just one callback, and that callback configures the props so that it describes how to make the props coming from React into reactive props, basically. But now we're adding a second callback where you get the return store value and a callback to update the debugger with state. So basically what happens is that we're looking at the value you return from the store, and then we just observe everything there. So if anything changes that you expose from the store, it will notify the debugger and update the state in the debugger. And later we will also be able to like, okay, which components is looking at what state and all of this stuff. And again, it just works out of the box, regardless of using like MobX, Legend, whatever. Yes, so that's the gist of what we're doing. So now I implemented MobX and tested that, and now we're implementing it for Legend. And I never used Legend before, so I'm a little bit so I don't think I can actually do this. Here I would have to do it. Yeah, sorry. So this would be set. Something like this. Oh yeah, so maybe not, we don't need list. Yeah, but here we need to get, I think it has like, does it have like, oh, it does have map. Yeah, again, I haven't used title get. Yeah, exactly. Like, I think Legend is very interesting. It's very interesting how they implement their reactive primitives and also how you consume them. But it's different, and I'm just not used to it. Let's see if this is actually running. Yeah, so we have the same thing. We're getting our state with the list. And if I were to change the name, oh, interesting. So we got the state update, but it didn't actually change in the UI. Isn't that weird? Oh, sorry. That's not weird. I keep forgetting. We need to use the Legend. Yeah, there we go. So that works. And if I add something to the list, it updates the state. So what we're looking at here is events that's eventually going to go into the debugger. Which I have a colleague that's working on the actual debugger. So I'm kind of prepping the backend for it, and then he takes over and actually cool. Okay, so that is Legend. I expected it to be simple. Like MobX was definitely the most like, I think we can actually copy this because it's going to be quite similar. So let's look at Preact. So it has, I think it also has observe, doesn't it? Or is it effect? I think it's effect. Yeah, it's called effect here. And it returns, yeah, unsubscribe. And then the question is, how do we identify that it's an actual signal? I guess maybe instance of. Yeah, it's a question of how do we want to do this in the debugger, because Preact has a signature of dot value. Yeah, but I think we can do this. So we say nested value dot value, right? Yeah. Yeah, I think this is actually the only change. Let's take a look. Impact React, Preact, yarn build. And then we're gonna go to this. Let's make sure we have Preact here. And then we're gonna do Preact instead. And they have, yeah, so this is gonna be a little bit different. So let's call it list. And let's just make this list signal. I think they call it signal, right? Signal from Preact signals React. So this is gonna just be this list. Oh, oh, excuse me. So now let's just return that list. And the thing now is, now it's a list.value, and there's no set. Yeah, so unlike that's the interesting thing about Legend, is that they use proxies to access state. But whenever you use .get to actually get the state, you will get just a normal JavaScript object or JavaScript value. So they have this really interesting balance of easy access, but you still work with immutable values. While Preact also, like impact signals, has like true immutable values, meaning that this list is like, this is the value, and if you want to change that value, you have to change it in an immutable way, just like you do with the use state in React. So we can't do this. We have to say equals sorry, so this equals state.list.value. Well, I guess how should we do this? We want to change, and this is why it's so horrible to use immutability. So we need to slice this on one, and then we're gonna change the first item here, and then that's gonna have this thing. And this is not really, I think I might have to do, or I think I can actually do this. Yeah, we're changing the first item. And then here we need to do something similar. Here we say state.list.value equals state.list.value. And then we add this thing. I think actually Legend is onto something, because when you have mobx, you just use immutability, mutation. So it acts like normal JavaScript. It's just everything's wrapped by proxies. But you can still just use normal JavaScript to push and do whatever you want. That's not the case with Legend. Like when you point to, you saw that when we pointed to like a string, a title, we still had to set that title. So it kind of creates this wrapper around your state, but you can still just use normal notation to access the state. But when you access it, you either have to get it or set it. Which is very, very interesting. Let's see. And then here we have value, map, and then we don't have to do this. So the thing about having this signature is that now you have to be a little bit more careful, right? Because now this whole array acts as one observable value. Unlike Legend and mobx, if you point to the title, you only observe the title. But here, if you access the list, you observe the whole list. But that fits better with React's model. And then you can argue the React model of like immutability and all that stuff. But yeah, it's very interesting. Okay, so we're getting our state here. Again, I'm changing the name. Blippity blop. Bloppity blop. Bloppity blop. And we're getting updates. As expected. Awesome. So that's Preact. And then we have signals. So I think again we can just copy the... We can just copy... Where is it? Preact. Let's just copy this. And then we're going to implement this for... Where's the store? There's the store. Right, and impact signals also has an effect. But there's actually, I haven't implemented any way to identify a signal. So I think we should change this. And the tricky thing is that these signals, well, the signal is split up into two pieces. Like solid.js, you have like, you did, maybe we can refactor it first. So you can kind of see how it works. So here we have a signal. I guess we have to manually from impact React signals. So here you would do this instead. So you would only expose the getter. So we cannot really, well, I guess we have to do set list. So here we would do state set list. And then state list. Yeah, or maybe here we can do like update, current. And then since we need a current list, like I wouldn't ever write code like this, just to be clear. We're just testing. So again, we wanna do state set list current. This will be current. And then list is actually something you call instead. Yeah, so this is basically, so there's no way, like this is the thing that's kind of, that is the observer. And that's the thing we need to actually track. But there isn't anything on it, that it's just a function. So what we need to do is we should it should be possible to identify that a function is like an observer, or that the signal function is an observer, that this is the function, this is the observer function, that is an actual observer function. A very easy way to do that is to add a symbol to it. Because there is absolutely nothing else, that it's just a function. So I think we're gonna do that. So we're gonna do the same thing, like is signal, and then we're gonna add a symbol to this, and then all is good in the world. But we do have a signal type, but we can have signal symbol signal, and then we're gonna have export function is signal. Well, this is the thing, this is a little bit confusing, like, because the signal itself is kind of both, right? It's the function to get the value and the function to set the value. So the signal is kind of like this array that you return. I think I should call it signal. Well, it is a getter. Yeah, let's call it what it really is. This is internal stuff. Is signal getter, value unknown, and then return type of value equals function and value and signal getter in value. That should be enough, and then we just need to add the signal getter to the thingy. Let's just call it function signal getter, and then signal getter. Let's just use true there, and then we'll have the implementation signal getter, and then let's do the same for this one. Let's call it signal setter. Function signal setter. Yeah, signal getter, signal setter. Cool. Impact React, signals, yarn build. Oh, sorry, I didn't actually implement this. Is signal getter. So that would be nested value. And if that's the case, we're just going to call it. I think that's it, actually. So now we're getting state. Oh, we're not getting any state. That's weird. Oh, did I build a... I think it just had the typing. Let's try again. No, what did I do? If is signal getter. So this is type of value equals function, and doesn't this work? thought that would work. Oh, wait a minute. I think I'm... Oh, this is interesting, because it's not only... This isn't the only thing that's a signal getter. We also have derived. We need to fix that. But let's make this work first. I don't understand what I did wrong here. Property doesn't exist on type function. It should be enough. I wonder what's going wrong here. Oh, is it running it? Oh, sorry. Sorry. There we go. My bad. So there we have it. And then I change the name. That's fine. And then we add that. That's fine. Yeah. So that works as expected. My bad. It's kind of a weird environment running all these packages next to each other. Where did I add that? Log. That was here, wasn't it? No, it was in the signal, sorry. But what we have to do the same with derived, because derived also has... So let's export signal getter. And in derived, we're gonna have the same thing. Oh yeah, we don't need this function. Signal getter or derived getter. So that would be this thing. And let's do this, and let's return derived getter. But let's first give it signal getter. So now this will work with if you're returning a derived as well. That is really a signal that only has a getter. Cool. I think this is it. So the only way this logic triggers is if you actually add, let's see in main here, you can see I'm adding a debug listener. So it only activates when you actually have a debug listener. So none of this logic will actually run when I publish new packages. But I don't think we really need to publish it yet. I'm gonna see if I can find some time with my colleague to actually test this thing. And store observe debug observers. Cool, but I think that's fine for now. We're happy about this, and then I'll probably do a stream when there's actually something to show. But yeah, for now, related to impact, I'm kind of just sitting on the fence a little bit, waiting for feedback, waiting for someone to like actually implement something with it while we work on the debugger. And then we'll have a release as soon as it's like someone says, yeah, this was great. This was a good experience. Cool. Thanks for following along, and then I guess we'll talk. Bye for now.